Okay, let's go ahead and take a look at our last of our 5 functions. And we're now on to number of periods. And we're continuing on with this idea of a $100 investment growing into $1,000. This time, though, we want to know how long it will take. And we're still going to follow this basic process, which starts with making sure we know how to document our assumptions. And so the first assumption we have, again, is a present value of $100. And I am going to key it in as a positive up here because that just makes sense for me as an assumption. I can always change the sign later when I use it as part of the formulaic calculations. I know I want that to grow into $1,000 again in the future. But now I have a fixed rate, which again is unqualified. So I'm going to assume that is an annual 10%. And what I'm really looking for is how long will that take to take place? So let's throw one of our standard little breaker lines in here. And let's think about our 5 variables. We know we're going to have present value. We know we're going to have future value. We're going to have a payment in here, which would have to be annual, but we don't have one in this case. So I'm going to highlight it and make sure all those are formatted as accounting. And then we know as we go to rate and then we go to time, we know that these all need to be synchronous. So we're going to highlight those in that light blue. So I'm going to, again, when we think about our present value as cash flows out as negatives, I'm going to do equals negative and point up here to the $100 because I want the 100 to grow into 1,000 while I'm making no payments. But this time I know my rate is standard at that 10% rate of return. And since I'm dealing with annual and I know that the formula below is going to draw from the text type above, I'm going to qualify it up top so that what I'm doing is calculating a number of annual periods. So for this last time, we'll go back again to formulas, financial, and if I find the one for numbers of periods, if I grow 10% annually and I'm making no payment, if I start with $100 that I want to grow into $1,000, then what that tells me is, uh-oh, we've got a problem in here. So let's see if we can't diagnose that problem. One of the nice things about doing this is once I have this formula in here, if I just click back on formulas and then insert function, it will bring up for us all of our different inputs. So let's see if we indeed did something wrong. And what I'm seeing is right here, I have my inputs right, rate B12, payment I have as B11, present value I have as B9, and future value I had as B10. But notice what I did up top is when I copied and pasted, I had forgotten that cash flows out as negatives were for present values, but cash flows in as positives is the way Excel thinks about it. So by not taking away that minus sign when I copied and pasted, Excel got itself confused. So I'm just going to go back and just do equals 1,000, and then lo and behold, if I go ahead and trim this down and just make it into a standard number format, then it would take over 24 years for $100 to grow into $1,000 if you earned a 10% annual rate of return. So that is our series on the way that time value of money in Excel will work for every problem type from future values to present values to payments to rates to numbers of periods.